Alright, so the first day of 5.5, we are going to find solutions of exponential equations and solve log equation using the laws of logs. So we're looking at our guidelines first, and we already did some annotations. So for exponential equations, when you're solving exponential equations, you want to isolate the exponential expression on one side of the equation. Okay, so get that by itself. Then you are going to take the log of each side. When you are taking the log of each side, you can take the log using the same base. What's another type of log you could do? Yep, you could do your natural log, or you could do your common log, which is just log base 10, which just looks like log. And then you're going to use the laws of logarithms to bring down the exponent. When it says bring down the exponent, which law are you using? Yeah, the power rule. So the power rule is something that we use a lot when we are solving exponential equations. And then you're going to solve for the variable. When you are solving logarithmic equations, you are still going to have the isolation, but it's of the logarithmic term. So the term that has your log in it. And then you might first need to combine your log terms. That is when you're going to use your laws of your logs to condense. Because you only want a single logarithm. Okay? If you have more than one, you're going to have to use your laws to condense them. And then after you have one log, you're going to write the equation in exponential form. Or you can raise the base to each side of the equation. That's what we talked about the other day when you exponentiate. Okay, where the bases become your exponents, and you get to pick what your base is. If you're writing an equation in exponential form, remember, if you have log base b of x equal to y, exponential form is, b to the y equals x. So this is the form that you're going to write it in. Okay, that's going to be your exponential form. So for our first example, we are going to be solving exponential equations. So we had to find the solution, and then we are going to round to 4 decimal places. Okay, so have your scientific calculators ready to go. For part A, we have 3 to the power of x plus 3 equals 5. Alright, so like I said, you can choose which log you want to take. You can have a log with the same base, you can have a natural log, or you can have a common log. Really for this, if you use the log with the same base, that's nice because it'll cancel out. So because your base here is 3, let's take log base 3 of both sides. So log base 3 of 3 to the x plus 3, log base 3 of 5. So again, remember we're using the power rule. If you have a log and an exponent, where does that x plus 3 go? Where does it go? In front, right? So you bring it down. So we bring down the x plus 3. And then we have log base 3 of 5. To evaluate log base 3 of 5, we can use... Yeah, do you guys know the equation from yesterday? Yep, which is the... Yep, so we are going to use the change of base. We're going to just write what the change of base is. So the change of base formula, if you have log base b of x, that means you can rewrite this as the log of x divided by the log of b. So that's what we're going to use on this side. Okay, because again, we only have our scientific calculator, so we can't just change our log. We're going to have to use the change of base. right, and then my last step would be to subtract 3 from both sides. So x would equal the log of 5 divided by the log of 3 minus 3. Okay, if we didn't use calculators at all, that's how I'd have you write your answers. But we are going to approximate to 4 decimal places. And you guys will want to practice with me. So if you do the log of 5 divided by the log of 3, you have to make sure you close your parentheses. Okay, if not, you will not get the same answer. A lot of times I like to press enter and then subtract 3. And then you're going to use your normal rounding rules. So negative 1, 5, 3, 5, 0 because you have a 2. Now if you're doing this on a test or a quiz, how could you double check to make sure you were right? Yeah, you could plug it back in for x. So if I did 3 to the power of negative 1.5350 plus 3, oh, I have 5.00. Why isn't it exactly 5? Yeah, because your answer was rounded. Okay, so if you use your exact, you would get exactly 5. Okay, so that can be a good way to double check. All right, for B, we have 2e to the power of negative x plus 1, and that is equal to 12. So remember, it said we should isolate the exponential expression. Okay, so Hannah, what should I do first for this? So really, we want to get the exponential by itself, but what's in front of it? And so you're going to, before you take the natural log, you're going to want to move over the 2 by dividing, right? So if you divide both sides by 2, these will cancel. You'll have e to the negative x plus 1 equals 6. Now your exponential equation is by itself. So basically you're looking at the base and making sure there's nothing multiplied to it and making sure there's nothing added or subtracted to it. All right, and then John, what log has a base of e? Okay, so I'm going to take the natural log of both sides. I'm just going to write it in the next step. So if you're looking back, you could see we had this and then we went here, which the natural log undoes e using the power rule. I'll bring that down in front. So I'll have negative x plus 1 equals the natural log of 6. I'll subtract 1 from both sides. And then I will divide by negative 1. Okay, and again, like I said, I like writing out what this would be without it. So the opposite of the natural log of 6, negative divided by negative, would be plus 1. Really, you could do this first and then divide by negative 1, and then we're going to round to 4 decimal places. Okay, so you can do that either way. So I'm going to use the natural log of 6 plus 1. And I get negative 0.79, and then it's 175, which means I need to round this up to 1/8. Okay, and that is my 4 decimal places. All right. All right, and then I'm going to give you C and D. So for C, we have 2 divided by negative 1 plus e to the negative x equals 10. And for D, we have 6 to the x plus 1 equals 2 to the x minus 3. Thoughts on how to start part C? Yeah, Joy? Good. Okay, we're going to multiply both sides by the denominator. That's where our exponential equation is, so we do not want it in the denominator. Did any of you think of it a different way? I didn't know if some of you were thinking of this as a proportion on how you could cross multiply. Really, you'll get the same thing, right? When I multiply this side by the denominator, what am I going to be left with? 2. So I'm just going to set 2 equal to, this would be 10 times your denominator. Okay, so multiply both sides by the denominator. That's how we come to this step. Now, if I wanted, I could distribute the 10, or really, I'm trying to isolate this. How else can I move over the 10? Divide, right? So I could divide both sides by 10. 2 over 10 is 1/5. So negative 1 plus e to the negative x. So now I'm trying to get this by itself, but I have the plus 1, or the negative 1, so I'm going to add 1. 1 and 1/5 is going to be what as an improper fraction? 6/5. Okay, now just like in part B, if I want to undo e, I have to do what to both sides? Natural log. So I'm going to take the natural log of 6/5, the natural log of e to the negative x, so that these will cancel. So natural log of 6/5, and then I'll just divide by negative 1. Okay, so x is going to be the opposite of the natural log of 6/5, and we'll round that to 4 decimal places. Do you guys have questions for me? Because I know some of the solving we're doing pretty quick. Okay, so then once we evaluate, did you guys get negative 1823.1823? Okay, so I don't have to round that up because of the number behind it. Just a note about rounding, remember that dominoes do not apply. So if you're rounding to the 4th place, you only have to look at the 5th place. Okay, and then that tells you if you bump it up or keep it. Okay, so sometimes like people are like, oh, but this was a 7 that rounds this to the 5, and then you bump it up. Nope, you only have to look at that one place afterwards. All right, what are we thinking about for D? So it's a little bit different than A, right? Because A, I did have 2 different numbers here, like as the base, but I only had a variable in one of my exponents. So I used log base 3. I can't do log base 6 and log base 2 because then I wouldn't be equitable. I'd have to do the same thing to both sides. Both would have to be log base 6 or both would have to be log base 2, or I could take what else? I could just do the common log, or I could do the natural log. Okay, I am just going to use the common log. So if I take the common log of both sides, and I'll narrate what we're doing here. So I'm going to do the common log of both sides, which would make this the log of 6 to the x plus 1, and the log of 2 to the x minus 3. Now I'm going to use the power rule. So the power rule tells me I can rewrite this, but this is a binomial. So when you're rewriting this, you don't want to just put x plus 1 log of 6, because that looks like x plus 1 times log of 6. You have to make sure you put it in parentheses if it's a binomial. So this is how you'd write it. So on this side, I'd write this as x minus 3 log of 2. Now here, you really do have some options. Is there anything you guys are just thinking, oh, I'd want to do this? What are you thinking?
You could divide the right side. Well, you could divide by log over 2 and x plus 1. Leave the left side with log over 2 over, log 6 over log 2.
So, so you want to divide both sides by log of 2.
And x plus 1.
Why? Both of them. see what you're saying.
I don't know still where.
I know.
The x-axis gets on
No. Okay, so you're saying divide both sides by
log 2 and x plus 1.
log 2 times x plus 1?
Yeah.
Okay, so if you did that, these would cancel out. You'd have x minus 3 over x plus 1. On this side, these would cancel out, and you'd have log of 6 over log of 2.
And you could change that to log base 2 of 6.
Okay, yep. Really, you change it back because you would evaluate. But you can make this into a number, and then what would you do?
Multiply by
X plus 1, and then you'd have to...
Add 3.
add 3 to both sides.
But you still have this, right?
Yeah.
So you'd have to do what with this?
You'd have to multiply it through.
So you'd have to...
Distribute.
Yeah, you'd have to distribute this, right? And you could, too, for, like, aesthetics' sake. You could do it like that. X plus log base 2 is 6. Yeah, why don't you try that, Nolan? Because you can get there doing that. I was thinking some of you would say that you would just divide both sides by log of 2 or log of 6. You could combine those. You could also distribute, right? I can distribute my log of 6. If it makes you feel better, no matter which way you do this, it's not really going to be that pretty. So if you do x times the log of 6 plus log of 6, go ahead and distribute on this side and write out what you'd have. And there are multiple ways to do this, which is why I want to see what you guys were thinking. So this would be x times log of 2 minus 3 times log of 2. Now, when you have this, you can kind of think of this like your inverse. Remember when we were finding the inverse and we had two y terms? What do we have to do?
You have to factor out the y.
Yeah, and before you could factor it out, they had to be on the same side, right? So see how I have one x here and one x here? I want to get all of the x terms together, so I could subtract, and really it doesn't matter which way you subtract. I'm just going to move this to the left. Can I subtract those?
Yeah. Same base.
They do have the same base, but it'd be the quotient, and you'd have to do it with the power. So we're just going to leave this. This is x times the log of 6 minus x times the log of 2. So you can't simplify that yet. And if I move my x's to this side, then I want to move my non-x terms to the other side. Again, you cannot simplify this yet. Okay? So this is going to be negative 3 log of 2 minus the log of 6. All right, so now we can factor out my x. Okay, so all we did here is we got the x terms together to one side. And the reason why we do that is so that we can factor the x. So if I factor out the x, I have the log of 6 minus the log of 2 equals, I'm just going to keep this the same. And then my final step to get x by itself is to divide. So I would divide the log of 6 minus the log of 2. Log of 6 minus the log of 2. Okay, so x is going to equal, I'm just going to write this out first before I compute it. So negative 3 log of 2 minus log of 6 over the log of 6 minus the log of 2. And then I'm going to do my computation. Now, if you do that all at one time, that's fine. You just have to remember that parentheses are your friends. Negative 3 log of 2 minus log of 6. Not only do you have to close this, but you have to close it for the numerator, divided by parenthesis for the denominator, log of 6, close it, minus log of 2, close it, close the bottom. So negative 3.5237. Good. Okay, and no one got it the other way too. And we'll just look at that real quick. Okay, so if you have this, right, your x minus 3, really when you're combining like your x terms, right, this is like a 1. You could also make this into a decimal. Did you make this into a decimal at this point? You did?
It was a lot of writing, but
Right. Okay, so we'll do that. I like GAs to see a different way. So if you have the log of 6 divided by the log of 2, really the only thing you'd want to make sure is that you keep this decimal in your in the memory bank. So you have 584962501. I'm just going to write that for now. X, right, plus this number again because it's times 1. So that 258 ... would be plus 1 equals x minus 3. This is usually the part that people do wrong. They move over the x, and remember that you're just subtracting 1x, right? This is going to be the 2.58 blah, blah, blah minus 1. So the 1.584962501 x, don't forget your x is going to go with it, and then you're going to subtract this value from both sides. Okay, which would just be negative 5, right, minus 3, 58, 496, 2501. And then you're dividing by this value here. X equals. Okay, so what I'm going to do is I'm going to subtract the 1 because that's what I did here. Subtract the 1. Okay, so now I have this 1.58, that decimal in there. So then when I do negative 5.58496501 divided by my answer, yay, I got it. Okay, so you could do that too. Okay, so you could turn this into your decimal. That would be fine. So just another way to think of it. Notice the note at the bottom says if the domain for a function is not all real numbers, you should be checking your solution because we have extraneous solutions, which we are going to talk about in a minute. What is the domain for A? All real numbers. Okay, what about for a B? All real numbers. What about for C? No.
No, because x.
Why is this one different?
Because it's x and then
You have the fraction, right? Okay, so if you have a fraction, you can't have the denominator be 0. You can actually just reason this out without even thinking of solving. Because this is negative 1, which would cancel out with what? 1. what's going to make this 1? 0, because anything to the 0 power is 1, so x can't be 0. Okay, so the only restriction on this would be x can't be 0. That wasn't our answer, though, so we're good. Okay, if our answer was 0, this would be an extraneous solution, and we'd actually say that there was no solution to the problem. And then for this one, your domain is all real numbers again. Now, when we look at the problems on the back, we're solving log equations. Log equations are different than exponential in terms of the domain, because with a log equation, what can't you do? What kind of numbers can you not take the logs of? Yeah, you can take the log of negative numbers or 0. Okay, so that's why we have to check for extraneous solutions here, is because of the domain. So you have to check all these on your homework to make sure they're not extraneous. Do you guys remember what an extraneous solution is? Not necessarily. An extraneous solution is something that appears to be a solution, but does not work when you plug it back in. Okay, and then some of you guys are going to need to make sure you pay attention when we go over the check for how to check it, like how to write your steps out. So the first one, you have log base 2 of 22 minus x equals 3. Now going back to our solving rules, we have to have the log isolated, and it is. There's nothing added or subtracted to the log. There is nothing multiplied by the log. So we can just go ahead to our next step, which is to rewrite this as, do you guys remember what form we have to rewrite?
Exponential.
Yep, so if we're going to rewrite this in exponential form, just remember where it comes from. If you have log base b of x equals y, your exponential form is b to the y equals x. That's your exponential form. Okay, so if you're going to rewrite this, Katie, what are we going to start with?
22.
That.
Wait, no, 2.
Yep, so start with your base. Good. So your base is 2. And then what's your exponent?
3.
Yep, and that will equal
22 minus x.
22 minus x. Okay, so all I'm using here is the definition, right? My base is 2 equals the exponent. You can look at your form, see how your x is here, and that's what it equals. And then your y value, okay, it was equal to 3. Now that becomes our exponent. Are you guys comfortable with this? All right, so now you can solve. So you have 8 equals 22 minus x. Subtract 22. What's 8 minus 22? 14. So then we're going to divide by negative 1. Okay, so now we are going to check to make sure it is not extraneous. So whenever you're checking, you are going to plug this into your original equation. So log base 2 of 22 minus 14 equals 3. You are not going to do any type of solving. You're really not going to work with both sides. You just want to work with one side of your equation and show that it equals 3. So 22 minus 14 is 8, right? And then you could show me this way, right? 8 is 2 cubed. What's going to happen here? Like cancel, so then you'll have 3 equals 3. Yes. Okay, so you're just showing the steps for how you're simplifying that one side of the equation. All right, so I know some of us are just going to have to practice that because we're used to doing a lot of things quickly in our head. So then when you're writing this out, you're like writing it out as a proof. right? You're proving to me, yep, that's how you simplify it. All right, now b is a little bit different because we do not have the log isolated. We have to move some things over. Okay, Anna, what should I move over first?
The fourth spot.
Okay, yep. And sorry, you said you're going to do what to both sides?
Subtract.
Good. Subtract 4, so I'd have -1 on this side. Don't forget your negative here. Okay, now you don't want the negative on the outside, so how do we move that over? Divide by -1. So I have the log of 3 minus x is equal to 1. Okay, now that the log is isolated, you are going to rewrite it as an exponential function. So go ahead and do that now. So you're going to rewrite it as an exponential. See if you can do it. Okay, so Julian, can you tell me what you got?
Is it 1 to the 3 minus x power?
Nope, so start with your base. And what is your base for this?
3, there's a 10.
Yeah, it's 10, right? Because you can't see it. So if you can't see your base, you are going to start with 10, right? That'll be your common log. Okay, so 10 to, and then what's our power going to be?
3 minus x.
Nope.
First.
Yep, it'll be to the first. So the way I remember it is whatever it equals is going to be your exponent. So I think, oh, it equals the exponent. So if it equals 1, 1 becomes your exponent. It's whatever the log is of that you're going to set it equal to. And then from there, you're just going to solve for x. So you're going to subtract 3 from both sides. 10 minus 3 is going to be 7. That equals the opposite of x, which means x is going to equal -7. All right, now let's check that. So I'm going to plug this back in to my original equation. 4 minus log 3 minus -7 equals 3. Okay, so 3 minus -7 is what? 10, right? Because it's really 3 plus. Okay, log of 10 is what? 1. 4 minus 1 is 3, so 3 is going to equal 3. Okay, but you need to show me like this step here. That way I can see, you know, the log of 10 is 1. Okay, and then 4 minus 1 is 3. All right, so if it checks, that means that is our solution. Okay, our next one is log base 2 of 3 plus log base 2 of x, and that's going to equal log base 2 of 5 plus log base 2 of x minus 2. Okay, so definitely a different setup than our other two because our other two had only one log in it. This one has multiple. So I have to condense my logs using my laws. Okay, so I want you to condense this one first. So think about what rule that's going to be, and then you can do the other side. So remember from yesterday we have the product rule, quotient rule, power rule. Robert, what rule do you think we're going to use for this one?
Did you say my name?
Mm-hmm.
Oh.
So look at your operation, right? What operation's in between them?
Addition.
Okay, and that goes with Does that go with the product or the quotient or the power? What's that? The product, yep. Do you remember how you write it? Think you can do it? Give it a go. Right? If you have these two added together, you can make it one log. You tell me what I write. It'll be log base 2 of, and then what are you going to do with these two? No, because we said it's the, what rule did you say it was? Yeah, the product, which means you have to do what with them? It'll be 3x. Yep, you're going to multiply them. Yep, so 3 times x, so it'll be 3x here. Okay, and then Reese, can you tell me what I have on this side? Sorry. Yep, so it'll be log base 2 of, and then, yep, 5 times, oops, sorry, not plus, x minus 2. Okay, so again, on this side, it was what rule? The product rule, right? So you're going to be multiplying those together. Let's go ahead and simplify this side. So if you do log base 2, this would be 5x minus 10. So we'll go ahead and simplify that part. Equals log base 2 of 3x. Now, usually when we had a log, we'd rewrite it as an exponential, but then we have another log on this side. The nice thing about these two logs is what? They have the same base. So it is like they cancel out, but really, since the log bases are equal, we know that whatever the logs are of are equal. So if this is log base 2 and this is log base 2, it's similar to what we were talking about with our exponents the other day. We know that 3x has to equal 5x minus 10. Okay, so if the bases are the same, you can set whatever the logs are of equal to each other. You could also use exponentiating, right? If I were to exponentiate, what would my base be on both sides? Wouldn't it be 2? So wouldn't I have 2 log base 2 of 3x would be equal to 2 log base 2 of 5x minus 10? And what would happen with 2 log base 2? Those would cancel, these would cancel, so we'd still end up here. So you could solve it that way. You can also just say, oh, if the bases are the same, yep, I know these are equal, and then you can go ahead and solve for x. So you'd have negative 2x equals negative 10, which means x is going to be 5. All right, now, when you're checking ones like this, some of these are going to be a little bit different. So you have log base 2 of 3 plus log base 2 of 5. And all you have to do is show me that on this side it would be the same thing. So if you plug in 5, this is log base 2 of 5 plus log base 2 of 5 minus 2, which is obviously going to be, what's 5 minus 2? 3. Okay, so this would be log base 2 of 3 plus log base 2 of 5. It'd be the same thing. Sorry, you guys can tell me. I can't see. Okay, so really for that, you don't have to evaluate, right? We can see that these are the same. Log base 2, this would be 3. I just switched the order on this side so that you could see they're the exact same. So then your solution is x equals 5. Don't worry, they're not all going to check. Okay, so for D, we have the log of x plus the log of x minus 1 equals the log of 4x. Okay, so go ahead and do the first step because I feel like based on part C, you should be able to do that now confidently. Okay, so CJ, what did you get on your first side here?
Log of x squared equal to x.
Okay, good. So you're multiplying these two together, right? Your x times x minus 1, which is going to be the log of x squared minus x equals the log of 4x. And then because they had the same base, okay, then you could rewrite this as x squared minus x equals 4x. You could move x over here, but this is a quadratic, which means you want what to happen? What were you going to say? Can't we just do what?
I was gonna say just divide by x.
No. Why not divide by x? Yeah, you're going to eliminate one of your solutions if you do that. So this is a quadratic. With quadratics, we want to move everything to one side so that you can, yes, you can use the quadratic formula. You can factor. Yep, complete the square. So we're going to factor. Okay, so you're going to factor to find your two solutions. You might have to factor a trinomial too. This is just a binomial, so if you take out the x, right, you have two solutions. So x equals 0 or x equals 5. So we have to check both of those. If you divide by x, then you're getting rid of your x equals 0 solution. All right, so then let's check these. Do you guys know before I even plug it in what's going to happen based on your equation? Yeah, because see how this is just the log of x? That means that you're going to have the log of 0. So really, once you get here, you know that there's a problem. This would be 0 minus 1, which is a negative. This would be the log of 4 times 0. What you're going to have to say to me is that there is an error. Okay, so I do want you to just plug them in so that we can see that. And then you just have to tell me what your error is. Okay, you only have to tell me one of the errors. Error, you cannot take the log of 0. If you want to say error here, you cannot take the log of a negative, that would be fine. Okay, it doesn't matter which error that you tell me if there are multiple. Okay, but you do have to tell me one of them. So that means this is an extraneous solution. I'm not even going to write it on my line. All right, let's see if x equals 5 works. If it doesn't, what would your solution be? None, right? No solution. Okay, if it does, then it would just be x equals 5. So this is going to be the log of 5 plus the log of 5 minus 1 equals the log of 4 times 5. So this is the log of 5 plus the log of 4 equals the log of 20. What can I use here to simplify? The product, right? Isn't this 5 times 4 using your product rule? So does the log of 20 equal the log of 20? Sure. Why not? Okay, so then your x value is going to be 5. Okay, how are you going to solve a quadratic equation? You can use the formula, you can factor. If you're feeling especially dangerous, you can complete the square. Okay, so kids are doing page 338, 3 through 13, 18 through 28, 37 through 41. Yes. Okay, so that's for your first day of 4-5.